Okay, for this screencast, we're going to start off looking at condensation reactions. Okay, and the first, well, I guess the definition we should start out. This is when we have two molecules that combine to form one product, and it usually releases a small molecule. Okay, so one larger product, but there is a release of a small molecule. A lot of times this will be water. Okay. The first type of condensation is when I have a alcohol reacting with a carboxylic acid. And that's going to form an ester. Okay, so say for the alcohol, I have ethanol. And I'm going to react that with, we're going to make this just methanoic acid. If I have, the conditions are going to be concentrated H2SO4. What's going to happen with this condensation is the, the OH group of the carboxylic and the H of the alcohol go to make the water, and I end up getting the ester. And this ester would be called ethyl methanoate. Okay. One thing to remember about esters, they are more volatile. Okay, because remember, when I have this ester grouping, right, I've lost this OH as part of the carboxylic, and I've lost the OH of the alcohol. So I no longer have this hydrogen bonding present in the substance because I no longer have a hydrogen directly bonded to an oxygen. So esters are going to be more volatile. They are fruity smelling. Okay, they are used in flavorings. Wow, that's flavorings. And they are also used in plasticizers. Okay. Okay, also remember, so that type of condensation was actually called esterification because I make an ester. If I have an alcohol, remember the R just stands for a long alkyl group. If I have a diol and a dicarboxylic acid, I have two places for these reactions to occur. Here and there making water, and also there might be another alcohol that can then react with this side. Okay, so if I have those functional groups on either side of those compounds, I can make a polymer, and this would be a polyester. And again, don't forget that the reaction conditions are concentrated sulfuric. Okay, continuing on the idea of condensation reactions, I can have a carboxylic acid and an amine. In this case, I would have some chain, my carboxyl group, reacting with my amine. Again, it's going to be that OH from the carboxylic and the H from the N. Make that an R prime just because it's going to be a different group. And what happens here is we form an amide. Okay, and this group here comes here. This ends up being the other substituents that's connected on the N. Okay. So if I start here, I'm going to use a different color pen. If I start there with a primary amine, I'm going to end with a secondary amide. Okay, meaning that I've got that functional group there now. Okay, if I start with a secondary amine, I'm going to end up with a tertiary amide. Okay, that should end this screencast talking about condensation. Next one will be benzene.